Hello everybody, my name is Sabrina. I'm going to be talking to you about data and how to manipulate data and how to use that with Python, as well as different files you may encounter, as well as a brief introduction to Jupyter Notebooks. So first of all, what the heck is a Jupyter Notebook, or a Python notebook, or a Google Colab notebook, or you can actually even do this in VS Code. So basically all it is a interactive Python environment that kind of saves variables in memory kind of in a certain runtime. You can run cells individually. It outputs things. You don't have to necessarily print it. The last line will output if it is something that can be outputted. And one other thing is that you can, create documentation inside of your code. And in this case, we call this Markdown. Jupyter Notebooks does it like this. Python or Google Colab lets you have a little bit more freedom with it without having to deal with Markdown as much. But basically, all Markdown is a way to make more nicely formatted comments / how to document things. You basically notate it if our cell is marked down. The less pound signs, the larger the text. You can do lists, and you can also do this to create a code snippet. So there's lots of different flexibility that you can have, and you can actually even embed HTML into this and let you document and make things nice and pretty. So that's Markdown. That's Jupyter Notebooks. The one other quirk of Jupyter Notebooks that I have gotten in trouble with is that we have set x equal to 4, right? But if we interrupt the runtime, that means let's reset all the variables. We're not going to remember anything. We're going to start from scratch. And I try to run 4, or try to run x, it give me error because it doesn't know what x is yet. But as soon as I run this cell, then it goes, okay, x is equal to 4, and then it works. So make sure you don't accidentally delete a variable, reset the runtime, and then you don't know where that variable is anymore, and then you get an error, and it's not fun. So don't do that. Alright, so that's Jupyter Labs, Google Notebooks. I would recommend Google Colab if you don't have Jupyter Labs already installed, just because it's easier. And then let's talk about file types. We're going to talk about 3 main ones: CSV, JSON, and text documents. You've probably seen text files before. Basically just laid out in a nice text format, just easy to read, simple, basically the backbone of most types of file types if you were to look at them as a human. Now we have CSV files. These are comma separated value files. They actually just look like this. They're text files separated by commas. However, our computer reads it as a more spreadsheet-like thing. If you were to open this and your Windows operating system, you would get a nice little Excel spreadsheet. In this case, my Jupyter Lab renders it as a more spreadsheet-like thing. But at the end of the day, it looks like this with commas separating all the values. And then we have JSON files. You probably have never heard of these before. These are called JavaScript object notation. Basically, it's a JavaScript type formatting to label data. They're used a lot when you're calling out to servers, getting information from servers. This server will send you back a JSON with all the formatted data. Basically, all a JSON looks like is, again, kind of a text-based looking document. But this time we have things enclosed in brackets. The first big bracket kind of holds everything, and then all these other little brackets hold, this object, and the third object, the third Pokemon. And, they have, the variable name, and then the actual, value of this unique object. So this is another file type that you may run into. So how can we use these file types, and how can we understand data using Python and Jupyter Notebooks with these file types? So first thing we always have to do when we want to explore data is we have to load in the data. I like to use the pandas library. It creates something called a pandas data frame. It's very nicely formatted, kind of does all the hard work for you without having to parse a file individually through some other parser or something. You just say, oh, I want to take the CSV and I want to read it. and then we will get a Pokemon CSV. Voila, all in there. We can also do that with JSON. These are going to look basically the same. Voila, JSON file. We can also do something with text files. In this case, the text file is a little more complex. We have to tell it to look at each comma, separate the information. We have to name the columns, or else we're not going to have any names, and that would be a little confusing. Then we have to input what text document we're going to use. And again, gives us a nice layout. Oh, this one. Oh, I read it out wrong. With text documents, if you don't have things nicely separated by commas, you can also delimitate things by tabs or new lines, and that will take everything that has a tab in it and create a separate data field. In this case, because we don't have any tabs, all the data goes into the first data field and everything else is empty or not. But we're not going to worry about that too much today. So Pandas data frame is the easiest way to read in data. After that, we can then explore data. We're not going to talk too much about trying to make sure that your data is perfect and doesn't have any nons or weird values in them. We're just going to assume everything works. But then we can start exploring it. So with a Pandas data frame, we can look at all these different columns. Name, type 1, just kind of format it like this, make sure it's in a string. We can get all these different values. We can kind of grab multiple at a time if we wanted to, etc. Then we can also find stuff like all the unique type 1 Pokemon, right? We have unique, we can find the number of uniques. There's a lot of different ones that we can do to operate on each individual column to find information about it. In your notebook, you will have a little tutorial that will talk you through all of them if you're really interested. But kind of just know unique, number of uniques as a very useful command. We also can do data analysis or get basic data out of our Pandas data frame. So here we're going to find the median. We're going to get the hp.median, and then we're also going to find the mean. And so in this case, median is stored in median, and it just prints out Pokemon the mean, which is 69.2587. We can also do this for variance and standard deviation, min, max. It will kind of give us the basic stats of our numbers if we ask it to. We can also do stuff like filtering, where we say, okay, we want to find everything greater than the median. Let's do median in this case. So this is criteria, and if we were to run the cell, we basically get an array of booleans. And then we could take that array of booleans, plug it back into our Pandas data frame, and it will give us a nice data frame of all the ones where the boolean equaled true. In this case, all the ones that were above the median. And then it's all nicely formatted. Beautiful. So you can do this to filter criteria. You can be we can find things are greater than the median, and a type 1 Pokemon is a dragon Pokemon or something. And this lets us kind of filter things and get the information that we want and want to use. So that's kind of the basics of Pandas. There's a lot in this library. It's really great, but too much to talk about in a video. And then we can also do something similar with JSONs. In this case, I'm going to encourage you to treat a JSON as basically a fancy array, where JSON index 1 stores the first Pokemon, and JSON index, or the second Pokemon, index 2 stores the third Pokemon, etc. And then we can also, this poke1 variable can also be indexed as an array. And so we can find, the third Pokemon's name is Venusaur. Beautiful. For your homework, you're going to take this information from a JSON and put it into an object, which you may be doing if you were to create an app or something. So that's kind of the basics. Index it, treat it as an array. Pandas does the hard work for you. And then finally, let's talk about graphing. With any type of data, you want to sometimes just figure out what it kind of looks like and, how the distribution of it, how many things are in each bin, etc. There's lots of graphs. There's histograms, bar graphs, pie charts, density maps. So there's lots of options out there. In this case, I would recommend just a nice bar graph or histogram. Really great graphs. For my graph that I'm making down here, I'm going to get all the Generation 1 Pokemon by using that filtering thing I used above. And then I'm also going to get the names of all the type 1s, the unique type 1s. And then, and this Generation 1 type 1 that are unique. And then I'm basically going to loop through each of those different types of unique Pokemon and find their average speed and put it into an array. And then I create a plot.bar using the matlib plot library to create a bar graph. And, put in the x variable, okay, all the different types. So height variable, which is going to be like the average speed of each type. And then say, okay, our data is coming from this data frame, which makes it a little bit easier for this to read. And then, got to label things. Label, X label, Y label, savefig, plot.show. Voila, we have a beautiful little graph that we can use. So in your assignment this week, you're going to be given a Jupyter notebook with 5 different tests and some resources. And you've got to use Markdown and read in a file, the data or the files. You've got to, find some general information from Pokemon. Use the JSON file to populate an object, and then they use that to check with our given method. Create a Markdown list, and then create some sort of graph. I would recommend bar graph or histogram because those are probably the easiest ones to do. And that is it. If you have any questions, hit us up on Colab, Discord, and I'll see you in office hours.